In the previous video, we talked about the mole, right? We talked about the fact that the mole is an elementary particle containing the amount of particles in 112 mass of carbon 12, right? That was the previous video of this course. Now, in this present video, we'll be talking about chemical formulas, because I forgot to mention this, but every chemical combination forms a unique compound, and that compound or molecule formed always has what is known as a formula. Now, there are different types of formula, but then let's talk generally about chemical formula before we talk about the different types of formula. So let's delve into. Today we're talking about formulas, types of formulas. We're talking about types of compounds, which are binary compounds, acids, acid radicals, metals, organic compounds. We're also talking about in detail. We're talking about the two major types of formulas, which are empirical formula and molecular formula. Then finally, I'll give a calculation on how to find the molecular formula from the empirical formula and vice versa. So let's move on. Now, I said earlier that a formula is basically an expression of the amount of atoms or particles in a substance, right? Now, those particles, they are often majorly atoms, or you can also have radicals too. So, and you can also have molecules. Yes, you can have units of molecules, different units of molecules inside a compound or another molecule. Yes, so you can have molecules in compounds, and this, whenever you express whenever you show the image of these substances, and then you also tell us the number of atoms of each of these substances, or the units of number of units, which are also known as atoms, because remember we said atoms are the basic fundamental units, right? So these units, these atoms, when we know the number of atoms, or the relative number of atoms, is known as a formula. And if specifically when we're talking about the relative number of atoms of each of these elements or substances in a compound, is known as an empirical formula, because it tells you only the relative number of atoms. So, and then basically when you have phosphorus 5 oxide, then you have P4. Oh, yeah. Now this is basically known as phosphorus 5 oxide. This phosphorus oxide, and then this basically, in this we'll talk about what is known as the valency. That's why I'm saying 5. So in a subsequent video we'll talk about valencies and governing powers, but today let's stick to what we're supposed to do. So, and now this P2O5 is basically the lowest ratio of the elements, because for every 5 oxygen atoms you see, you have to see 2 phosphorus atoms. So, and lest I forget, the symbol for phosphorus is P, the symbol for oxygen is O. Now, but that's called the empirical formula, because it's telling us the simplest ratio. Just like you have when you break things down in mathematics to the simplest form, that's called the simple ratio, right? Now this simple ratio is 2:5, but actually one molecule of phosphorus oxide or phosphorus 5 oxide consists of 4 atoms of phosphorus and 10 atoms of oxygen. That is P4O10. That's the molecular formula. For the empirical formula, it's called P2O5. So that is the difference between empirical formula and molecular formula. And lest I forget, every compound, every substance, every molecule has its own specific empirical formula or molecular formula, and they could be the same, because there's a formula we have which says that molecular formula is equals to n open bracket empirical formula close bracket. So, and your molecular formula is often always the multiple of an integer with your empirical formula. So whenever you multiply an integer with your empirical formula, you get your molecular formula. In the case of P2O5 and P4O10, the molecular formula P4O10 is gotten from the empirical formula by multiplying by 2. So when you multiply P2O5 by 2, you get P4O10. So that was just an explanation of what empirical formula and molecular formula means. So, but what are we getting the formula of? Formula of what? Now we could get formula of binary compounds. For example, phosphorus 5 oxide, that is also a binary compound. So this is the formula of phosphorus 5 oxide, the molecular formula, which is P4O10. That's what's known as binary compound. We also have what is known as acids. So I don't know if you've known beyond this, but basically acid is basically a substance which liberates hydrogen ion or hydroxonium ion as the only positive ion when dissolved or ionized in water. Now basically these acids, the example of acid that are hydrogen chloride, that's called an acid gas. We also have tetractylsulfate 6 acid H2SO4. Tetractylsulfate 6 acid is H2SO4. So, and then let me use this 2 as an example. Now, what this is telling us is from this formula, as you can see, is that what this is saying is that for every one hydrogen atom you see in HCl, which is hydrogen chloride, the formula for the symbol for H of hydrogen is H, the symbol for chlorine is Cl. Now, for every one hydrogen atom you see, you have to say another one chlorine atom. So HCl is in ratio 1:1. So, and then for in the second one, where we have H2SO4, that 2 after the H, which is a subscript, and that tells us the relative amount of atoms of that substance. So when the subscript that comes after H, which is H2, tells us that there are 2 atoms of hydrogen. Then we also have this SO4, this S, there's no subscript, so that's automatically 1. There's 1 atom of sulfur, and then this subscript after the 4, O4, means that there are 4 atoms of oxygen in roughly relative amount. So basically, that is what is called, that is how you can see formulas. Then you also have what's known as radicals. Now, in the previous video, I made an attempt to explain radicals, but today I'll complete it and give an example. And a radical is basically a group of one or more ions which carry a charge. So, basically, you have this acid radicals is basically the negative ion. So these radicals, they could be anions or cations. So the hydrogen part is the anion part, is cation part, which is positive. You have 2 when you do what is called electrolysis and decomposition. We'll be talking about that in a later video. But when you decompose them, this H2SO4 decomposes into 2 atoms of hydrogen, 2H plus, and that hydrogen is called hydrogen cation. Then plus 1 radical of tetractylsulfate 6 radical. So that's the ion because it has a negative charge. So that is this part is called SO4 superscript 2 minus. It's called the radical. So that is just that's how you often say radicals. Then we also have metals. So your metals, example of metals are your copper, your iron, your gold, and different. So these metals, they have their different physical and chemical properties, which we use to identify them. But then these chemicals, they also have their own formulas. And before you can know formulas, you have to know the relative we have to know the name of the symbols for all these elements. For example, copper is Cu. So copper is formed from when you there's an old name of copper known as cuprum. So it's formed from the old name Cu from the first 2 letters. Then we have iron. Iron is Fe. Fe is formed from the Latin name. So we have silver is Ag. So, and then we have tin is Sn. So these are all metals. So tin is formed from the Latin name stannum. So we take the first and the 3rd letter of that Latin name. So when you know the representation and the symbols for the elements, you can easily understand how to represent them. So for example, if you have two ions of copper, you have to put a number behind it, the coefficient. That's 2 Cu. Then you put the ion plus, because the copper is a positive ion, and metals always form positive ions known as cations, but non-metals always form negative ions known as anions. So there are exceptions to this, but we'll be talking about that later on. So then we have what's called organic compounds. So we'll talk about organic compounds, but they also have their formulas, such as alkenes, and alkynes. So you can also check that out in a video of this channel. But today, to round off, I'll be talking about how to calculate the molecular formula from the empirical formula. So, and it goes like this. Now we have this question which says that a compound consists of 0.424. The ratio of copper to oxygen in the compound is 0.424 to 0.107. So and then we have to find the empirical formula. So and then basically what we'll do here is we divide by the atomic mass. So that's actually the relative atomic masses. So the relative atomic mass of copper is 64. That's divided by 64. So that we divide the 44 by 64. Then we divide the 0.107 by 16. So at the end of the day, to give us 0.107. 0.107. So when we divide them to their lowest term, to give us 0.107, 0.107, and then when we divide by the lowest numbers, we'll get 1:1. So this is the simplest ratio you can find copper and oxygen in copper oxide. That is known as copper 2 oxide. Thank you for watching.